Good morning, San Diego. We're live from Rexburg. This is Matthew, Mason, and Aaron, the Group 3. Lesson 7. Yeah, I thought this was a good section. Good read.
Yeah, as a review of that last one and the one before.
Yeah.
What?
So, I get started. The two conditions that must be satisfied are the parent population needs to be normally distributed, and the sample size needs to be large enough for there to be a normal distribution.
Agreed.
Oh, yeah. Okay, that makes sense. It's either got to be the parent population is normal or it's got to be above 30 for the sample size. Okay, number 2 is what is the z-score formula for a sample mean that's normally distributed? And that one is you take the value minus the mean, and you divide it by the standard deviation divided by the square root of the sample size.
Close.
So,
Yeah.
a lot of words, but
You need to subtract the average.
Value minus the mean divided by the standard deviation.
yeah, but you've got to make sure that the bottom, the standard deviation divided by the square root of n, that's got to be in parentheses.
Right.
I kept doing it because I hadn't looked it up yet, and I just heard it from you guys, and I kept messing up because I didn't realize it was like, I don't know, I didn't realize what the fraction was or what was supposed to be on the bottom. Wow.
All right.
I thought number 3 was
so-
a deal. You want to do 3?
Yeah, Aaron, did you want to do number 3?
Sure.
Okay.
Right. Number 3, suppose. All right. So the mean is 10, and then the deviation is 5. So what is the probability of randomly selected individual observation between 5 and 15? So if you do the old z-score, so just the number minus the average or mean divided by the standard deviation, you get -1 and 1. And so this is 68% because it's just like that rule, 68,
Yeah.
59.
Which makes sense because it's the
Yeah.
5 and 15 are 1 standard deviation away from the mean. So
Yeah.
And then 40th percentile just popped in, 40% into the applet, got a z-score of -2.53, multiplied it by the standard deviation, then added the mean, and you get 8.735. Does that have any questions on that one?
Maybe, I don't know. One sec. Maybe I did that one wrong. So it was on the applet you put 0.4 in the area for the left side. You get a z-score of negative 0.25.
Yeah.
Okay, and then you multiply that by the mean or the standard deviation, and then what do you divide?
Then you add the mean.
So the standard deviation was 5, and then you add the mean, which was 10.
Yep.
Oh yeah. Yeah, I don't know what I did the first time, but I didn't. It came out wrong, but okay, that makes sense.
What is the z-score for an observation of 18.5? this one was just 18.5 divided by 5. And so it's 1.7 for the z-score. What is the probability that an individual observation is greater than 12? So this one was either 12 minus 10 divided by 5. Got a z-score, plugged the z-score in, and it's 34%.
Yeah.
And then the next one was the probability that it'll be less than 8 or greater than 12. They're both going to be 34% on both sides. And so 34% plus 34% equals 68%.
Yep.
Wait, how do you do that one again, Aaron?
So you do the same, so you'll get the same z-score that you did on 10 for 8 and 12. And so
Yeah.
what's that number? So whatever that number is. So they're both going to be 34% on the right side and 34% on the left side. And so it said, what's the chance that there will be less than 8 and greater than 12?
Just highlight the middle.
And then you can add two percentages together.
Okay. Oh, yeah. Okay. Cool.
Or you could subtract the middle part. Who got number 4?
I'll do not the rest, but I'll do the next couple. Suppose pair computing sold an average of 45 phones per minute in 2011. Yes, that means they sold that much phones in 2011 with a standard deviation of 10, and they looked at their phone sales data and determined that they are normally distributed. For samples of size n equals 4 are taken from the normally distributed. I say distributed weird. Sales data. What is the shape of the distribution? I put that it's normal, right?
Yeah, because it was normal the whole way.
Yeah. And then I'm pretty sure number 5 is the same thing with normal again, right?
Yeah, because
Yeah.
it goes along with number 1, where the parent was normal and it's a large sampling size.
Yeah.
Yep.
And then, do you want me to do 6 too? I'll do
Yeah,
6.
just go all the way to 9, and then the last one, or the last 5.
So a sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed value is less than 40? For this one, I got 0.157, which is 16%. Right? So you guys got?
Yeah.
Yeah.
Okay. Did you say you wanted me to keep going, or did you want?
Yeah, just go to 9, and then I'll start at 10 and go to 15.
Okay. So number 7, a sample size is taken from the normally distributed to what is the probability that the observed is greater than 35 and less than 55? So for that one, I ended up getting 95%, 0.95. Is that right?
Yeah.
And
Yeah.
number 8, what is the probability the value is greater than 41 and less than 49? That one is, I got 95% again. No.
Is that is kind of interesting that because on problem
7?
yeah, wait one second.
They changed the sample size. That's why I know I looked at that too. I thought I messed up.
Yeah. Because it's
Well, I guess the same.
it goes from 4 to 25.
That's weird. Why would the sample size change the probability?
Well, the sample size change and the like, let's say the answer you want to get on the test change as well. So going from 35 to 41.
Yeah, I think it's just a coincidence, I guess, but everything changes in the problem.
Yeah, that's true. Yeah, they found like it's just funny. It seems like they found the perfect like if we increase the sample size but decrease the area that it's covering, like there's got to be some parallel there.
Yeah.
Because 7 covers 2 standard deviations, and 8 only covers 2 standard deviations, and 8 covers not even 1 standard deviation, but it's the same
Well,
probability.
it covers 2.
What, 8?
Yeah, if you do 41 minus 45 divided by 10 divided by square root of 25, you get negative 2.
Oh, maybe. Yeah, it's just That's interesting. So the sample size.
Do you want to do number 9, Matt?
Sure. Sample size of 25 is taken from the normally distributed 2011 sales data. What is the probability that the observed value is greater than 50? So for that one, I put it was a really small. It was like 0.006.
Yeah.
Yeah.
And then for the next questions, it changed a bunch of stuff. The average is now 40 per minute in 2010. Standard deviation is 12. And for this one, the data was right skewed. So for 10, it says the sample size is 4. And so it's asking what is the shape of the distribution. And because the sample size was only 4 and the data was right skewed, I think it means that the sample will also be skewed to the right. And then for 11, because it's 40, which is greater than 30, this also kind of answers 12. It's because of the central limit theorem that now the data will be normally distributed. So for number 13, you can't use it because you can't use the applet in 13 because the sample size is too small. But in 14 and 15, you can use the applet. And in 14, I got a probability of 0.9599. Is that what you guys got?
Yeah, so 96%-ish.
Yeah. And then for 15, sample size of 36 is taken. What is the probability that X is observed between 37.5 and 42.5? I got that it's the 0.1056 for less than 37 and greater than 42 is the same thing. So the answer is 0.7887.
Sounds good.
Yeah, that was all of the individual prep. But did anyone else have any questions?
Oh.
I just want to be able to know all the formulas, before the test and everything.
Yeah,
I guess they're really not that hard.
We could go through and find them. Like, it seems like it's the value minus the mean divided by the standard deviation. But the only time the standard deviation, unless it's a sample size, and if it's a sample size, then the standard deviation is divided by the square root of the sample size.
The square root of it. Why is that so?
Honestly,
I guess
I don't know. It's like on that one question. I don't know why dividing by the sample size, like changing the sample size, it just makes the standard deviation smaller, which I feel like that would change the data.
Yeah. Why were the students and we didn't invent all this stuff.
We could post on one of the discussion boards that question. But, okay. Well,
I'm
anything
down
else,
to
Mark?
take this quiz.
Okay. I'm gonna end the chat.
All right.